Energy is a word that we keep using very frequently in our daily life. But what is the scientific meaning of this term? That's what we want to find out in this video. So according to physics, energy is the capacity to do work. Now before we try and figure out what this statement means, let's quickly recall what work is. In physics, work is the force acting on an object multiplied by the displacement of that object. This means to do work, you need to push on something and make it move. So what is this statement saying? This statement is basically saying that anything that can do work has something called energy. Okay? So if you can do work, you have energy. That's the basic idea behind it. So anything that can push an object and make it move must have energy. All right, let's look at some examples. This lady can push on this cart and make it move. So she can do work on that cart. Therefore, she must have energy. So all living things can do work. So all living things must have energy. But can non-living things have energy? Let's find out. If I take a cricket ball and throw it at the stumps, then it can do work on the stumps, right? I mean, the ball pushed on the stumps and it made it move. So the ball had energy. Let's take another example. If I were to drop a hammer onto a pin, then it can do work on that pin. It pushed on that pin and made it move. So the hammer also had energy. So what's common in both of these? Well, over here, before the ball hit the stumps, it was moving. So you see, moving ball has the capacity to do work, and therefore it has energy. Similarly over here, before hitting this nail, the hammer was moving. So moving hammer has the capacity to do work. It must have energy as well. And so can you see that any moving object must have energy? The faster it moves, the more energy it should have, right? Because it can do more work. And so we can give a name to this energy. We can call this moving energy. But in physics, we give a more technical term. It's called the kinetic energy. And so energy of an object due to its motion is called kinetic energy. And some other examples will include wind. Wind is moving air, so that's kinetic energy. Even waves in water have kinetic energy because there also we have motion. Okay? But guess what? We can also have energy without motion. Let's take some examples of that. Suppose we take a spring and compress it. Now, if I keep a paper ball in front of it and let go of my hand, you can imagine it can do work on that paper ball, right? Because it can push on that ball and it can make that ball move. That means this compressed spring has capacity to do work. It has energy. Notice that spring is not moving, yet it has energy. Similarly, if you take a stretched rubber band, that should also have energy because even that can, shoot a paper ball and do work on it. Okay, now the question over here is, what does this energy depend on? For example, how can I increase the energy inside this spring? Well, you might know if I can compress it more, then it'll have more energy, right? Because it can now shoot this ball with much higher force, doing more work on it. So compressing the spring has increased the energy. Similarly, if I stretch the rubber band more over here, it'll have more energy. So over here, what does the energy depend on? The energy depends on how much you compress or how much you are stretching this object. So in general, we can say over here, the energy depends on the configuration of the object. Basically, it means how you are arranging that object, how much you're stretching or compressing it. Now, before we give a name to this energy, let's look at one more example. If I take a ball and raise it to some height, and let's say I drop it, then gravity can do work on that ball, right? Because gravity can pull on it and make it move. Ooh, that means gravity itself must have energy in it. It's a little hard to think about it, right? Because we can't see gravity, yet it must have energy because it can do work. Now again, the question over here is, what does the energy of gravity depend on? You think about that? How can I increase the energy of the gravity over here? Well, I can just raise that ball higher, right? Because if I raise it higher and now I drop it from here, the force of gravity would be the same, but now it can displace more. That means gravity would do more work. Ooh, that means the energy of gravity has increased. So the energy of gravity depends on the height. Higher I go, more gravitational energy. So in general, we can say it depends on what? It depends on the height, or we can say it depends on the position of this object, right? So over here, the energy depends on position. But again, to talk about the name of this energy, what should we call it? Can you think of something that's common in all three of this? What do you think is common over here? Think about it. All right. In all these cases, if I let go of my hand, the objects will gain kinetic energy. Think about it. If I let go of my hand over here, the ball will get shot like this. Here also this ball will get shot like this. Here also, if I drop the ball will go down, increasing its kinetic energy. So it's as if in all the three cases, they are waiting to become kinetic, right? These energies are waiting to become kinetic. And that's why we call these energies potential energy. So the word potential is basically saying these energies are waiting to be kinetic. It's not at kinetic yet, but it's potential. It's just waiting for it, okay? And what does potential energy depend on? Well, it can depend on the position of the object, or it can depend upon the configuration of our objects, all right? So over here, we can say the energy in gravity is gravitational potential energy. Similarly, over here, we can say the energy is elastic potential energy, because the energy is coming due to elastic forces, right? Due to the elastic nature of the material. But they're all potential energies waiting to become kinetic. And there could be other kinds of energies as well. For example, we might know light itself is a form of energy, but does light do work? Can light push on things and make it move? Well, in our day-to-day life, we may not see that happening, but if you had a very powerful source of light, then it could happen. In fact, you know what? In future, we think that's one way of space travel. For example, the idea is we can have a spacecraft and just shoot a very, very powerful laser from the Earth, and that if it has enough energy, that laser can start pushing it and, you know, make that spacecraft move, accelerating it. So yeah, light does have energy. It can do work. It can push on things and make them move. And of course, there could be other kinds of energies as well, like heat energy, sound energy, electrical energy, chemical energy, and so on. And you might learn about them in the future. But once you do, you'll see that they're actually a combination of kinetic and potential energies itself. And that's why kinetic and potential energies are super, super important. And lately, you might have heard of this another thing called dark energy. This is something which nobody knows about. We don't even know whether this exists or not. Nobody has seen it. People believe that this should happen because people think that that's what's causing the universe to expand. Definitely fun stuff to read about, but this is something that we have no idea about as of today. All right? So, let's quickly summarize what we learned in this video. Anything that can do work must have energy. And we mainly saw two kinds of energies, kinetic energy and potential energy. Kinetic energy, the word kinetic stands for motion, so it's the energy due to moving things. Anything that is moving can do work, and so it must have energy. Faster it moves, more kinetic energy it has. Potential energy is the energy that's waiting to become kinetic. That's one way to think about it. And what does it depend on? Potential energy depends on the position or the configuration. So for example, if you look at the gravitational potential energy, that depends on the height of this object. For small heights, it can do less work, so less potential energy. At higher heights, more potential energy because gravity can do more work, so position. But we can also have configuration. One example of that could be springs or rubber bands. So if you take a spring and you compress it a little bit, less potential energy. But if you compress it more, then you'll have more potential energy.